Okay, so in this video here, we're just going to have a quick look at our new solid phases in our results file. So I've just opened up ParaView. Maybe I should close that. I just opened up ParaView in the same way we did previously. ParaView mynewcase.openfoam. And the second time you open ParaView, it loads rather quickly. Okay, so you see this is my mynewcase.openfoam here. I'm going to come down to this properties tab, and I'm going to scroll down and just choose the things that I want to display. So, for example, I probably want to see the water volume fraction, temperature, air volume fraction, coarse and fine, mass fraction, sorry. H2O and air are actually mass fractions. And so here are our new mass fractions, our new particle sizes, 250 microns and 500 microns. So once you've chosen everything that you want to display, we can click apply, and well, we get this thing. So this is our domain. I can rotate it around. You can see it's cylindrical. It's slightly bigger than the last case. Okay. So I'll set this button here just views from the x-axis here. So we're looking at the side on now. And what I'm going to do is I'm going to take slice right through the middle. So I'll press this button up here called slice, and automatically that chooses a slice that's going through the middle of this domain. Okay, so I'm going to click apply, and it gives me my slice. I want to display, well, let's just start with the fine particles. Okay, so here are the fine particles at time 0. Let's just, for the sake of visualization at the moment, skip to time 94. And you can see there's some dust in the air here. Again, same as last time, we're going to change the color scale so that we can make it look all pretty. So we'll go to HSV, and just to get a better visualization, I'm going to take the slider down quite a bit. So you can see that there is some fine particles that have been ejected through the plume and then have reached some buoyancy height, some neutral buoyancy height, and spread out throughout the domain. So adding the extra height to my domain and reducing the mass volumetric flow rate out of the, the mass flow rate out of the vent. Now our simulation stays within our domain, at least vertically. Horizontally, well, I think this was an 80 kilometer domain by from memory, so 40 kilometers in radius here. And well, it looks like the fine particles spread further than that, but okay, this isn't too bad. So what I want to do now is I actually want to move this slice up into this, well, let's say, yeah, up into a corner here. So what I'm going to do now is come down to this properties tab, making sure I've clicked on slice here. And maybe I can rename that actually. Let's rename that if I can. Oh, well, it's not so easy, so I'll leave that. Okay, come to the properties and we'll slide down here until we hit transforming. And so this is going to let us move our image. Well, this is the X, Y, and Z transformation. So let's move this, let's say, negative 40,000 to the left. That may be the wrong way. So let's just go 0 for now. Let's try and move this up 40,000 to the, okay, so I don't quite know why this is not X, Y, Z, but okay, it seems like, okay, I see. So X is actually pointing towards us, Y is pointing to the left, right, and Z is pointing up, down. So we need to move this, let's say 50,000 actually, and we'll move it up another 50,000. Okay, so now I have my fines up here. The reason I'm doing this is because I want to try and put them, all the 4 particle sizes on the same domain, on the same plot. Okay, so this is for the fines. Let's go back to mynewcase.openfoam and click slice again. Because this time for slice 2, well, click apply. for slice 2, I might like to look at the 250 micron particles. Again, I need to change this slider here, so let's look at it like so. And again, I'm going to translate it. So I'm going to scroll down here. This time I'm going to move it, let's say negative 40,000. And again, I'll move it up 50,000 so that it's sitting next to the other one. Or maybe I'll move it negative 35,000. I'm going to do the same thing for the other 2 particle sizes. So apply to 500, so the 500 micron particle size, H is V. I'm going to slide this down. You can match up these numbers exactly between the different cases, but okay, I'm not that interested in doing that right now. This is just a demonstration. Okay, and I want to move this one again. I might just translate it 50,000 and not move it up. Okay, good. And then finally, I need the coarse particles. Coarse particles. Change the color space. Oops. Okay, and then I'll translate it again. Let's go negative 35,000. Okay, so now I've got these 4 plots, the fines, the 250 micron, the 500 micron, and the coarse particles, all on the same scale here. Oh, sorry, all on the same plot. And so I guess the only other thing is this annoying outline here. So I'm just going to come up to the properties, and right at the top we have plane parameters, show plane. I'm going to uncheck that, and well, everything looks good. So let's just go back to time 0 here. Oops, I clicked something wrong. It's not, my mouse is doing something funny. Okay, good. So we're back at time 0 here, so there's no solids in the domain. Remember, this is the fine. I could probably change the ordering. You could probably ignore these legends over here, but just remember that this is the fines, 250 microns, 500 microns, and coarse. And let's just watch the evolution of these different particle sizes. So of course, 250 microns is quite small, so it's relatively close to our fine particle size. So actually, the 250 microns is relatively close to the fine particles in terms of what their dynamics and when they spread to. The 500 micron particles is about half a mil, so it's relatively close to our 1 mil particle size. So you can sort of see here that well, this 500 micron particle size is somewhere between the coarse and the fine particles in its dynamics. And so you can see, really, only see in these coarse particles, you could see them, these particles start to be falling down to the ground and being deposited. Whereas really, well, the 500 microns are sort of starting to do that, but I don't think they've quite reached the ground yet. And the finer particles, the fine particles, and the 250 microns still seem to be pretty much completely suspended in the air. So one thing we do want to keep in mind is when we're going to be looking at deposition of particles, we're going to have to make sure that we have a nice fine mesh so that we can get good resolution on the ground surface here. But okay, that's the tutorial. We've added in these 2 new grain sizes, 250 microns and 500 microns, and just seen what their dynamics are like. Maybe you could try this again and add a few more grain sizes, because we've added 2 here, but you're welcome to add as many as you like, really. And you don't have to add only solid particles. You can add an extra gas phase, for example. Maybe out of your volcanic plume, you're also ejecting CO2 or something, or some other gas. So you can add extra fluid phases in too. And in fact, one thing I might do before we finish here is I might just add in some gas phases into this plot here. So I'll create a new slice. I'll apply. Let's plot the water vapor phase. Again, HSV down here. Let's translate it. Where'd the translate go? So we're going to move this 50,000 and maybe negative 40,000 here. Maybe negative 50,000. Okay, good. So we can also add in the water vapor. We can add in the air phase if we like. Where's the air? HSV. There we go. Diverging. Well, it's harder to see in that, isn't it? Well, yeah, okay, we'll just do it like this. Because, of course, the air is different because it starts at 1. And so it's lower, actually, in the eruption. But again, I can translate that if I can find I can translate that negative 35,000, negative 50,000. And so we can view not only our 4 solid phases, but then our 2 gas phases as well, our water vapor and our air phase. And we could watch the dynamics of how that evolves too, if we like. Okay, well, thank you for sticking around and watching this tutorial. Hopefully you'll give it a go yourself, and we'll be adding more tutorials with things like how do we add in a wind profile into our eruption, and then probably also eventually some adding Lagrangian particles into our eruption, as well as analyzing post-processing as well. So how do we plot the a parameter over time at a specific location, or we could plot a contour plot of the deposition of particles on the ground. Those are for future videos though. Okay, thank you very much.